For this example, we want to find the partial fraction decomposition of 10x plus 35 over x plus 4 quantity squared. So, because in this case we have that repeated factor on the bottom of x plus 4, what we're going to do is take that and split that up in terms of a 10x plus 35 over x plus 4 quantity squared being equal to an a over x plus 4 and a b over x plus 4 squared. We just take the repeats in terms of the next one down from the smallest here being a linear term, so it's just going to be a whole bunch of constants. Here, 2 of them. And that, when multiplying over the x plus 4s, is going to leave us with a 10x plus 35 equals a times x plus 4, because we multiply 2 of them, we'd get 1, and then plus b, because there's actually nothing left over there. We're all done, essentially, at that point with b's. So, we don't necessarily have a nice value that we could plug in to get a, but it is very easy to get one for b. In particular, if we're going to plug in here x is equal to -4, then we should hopefully be able to tell that what we would get is 10 times -4 plus 35 equals a, oh, I wrote that a so small, a times -4 plus 4 plus b. Let's curve that just a little bit more, where this on the other side would simplify down to -5 equals, oh no, b is -5 again. I swear that b isn't always -5. It wasn't in that really simple case. It's not always. Anyway, we have this for our value b. And then from here, because we have the value b, we can use whatever we want to get a. So in particular, I'm going to use x is equal to 0, where, because I get to use 0, it's an easy one, what we can do is say that 10 times 0 plus 35 is equal to a times 0 plus 4 plus b, which is -5. So that, with some finagling, turns into 40 equals 4a, or a is equal to 10. So if we want to take that undecomposed, that I guess you would call it living, I don't know, rational equation, we could turn that into 10x plus 35 over x plus 4 quantity squared, instead as 10 over x plus 4 minus 5 over x plus 4 quantity squared. And that's not terribly uncommon when you're dealing with these things, especially in this form, that you get one of your values, a or b, happens to match up with one of the coefficients of the numerator to begin with. They should end up coming together really nicely in that way. And essentially, this is how you run any partial fraction decomposition. So to finish us off for the week, we're going to look at the way you can handle these things in terms of more complicated factors in the denominator. We're not going to go through examples there because we've got quite enough for this week already, but I'm going to at least show you how you would set something like that up.